For Project 4, we were assigned the Armfield distillation column in the senior lab to calculate the Murphy vapor efficiency of each tray in the distillation column through the separation of a mixture of methanol and water with total reflux. We attempted to model our batch distillation column in software, and this video walks through our process and the data that we were able to obtain. To begin, we tried to model our process in Aspen Plus. We thought that this would be our best bet for our batch distillation process, as there was already a batch distillation model for the separation of methanol and water created within the software. We began using this and were even able to set the tank to the shape of the one we have in the senior lab. From there, we entered arbitrary values for the mass boil-up rate, as it was a required specification to run the software, but not a part of our project. Once we had done that, we entered the process variable that was being changed and opted to change the stage efficiency. We were able to obtain efficiencies of around 93% in our project, so this is what we utilized here. Once all the required inputs had been specified, we were able to run the simulation. However, we were not able to get the simulation to converge and produce results. This could be due to the fact that the model was a bad fit for what we had, and also that we were not able to specify anything at all, so it never produced the results that we were expecting. Moving on from Aspen, we decided to see what other software was available to us through VMware Horizon, and stumbled upon Super Pro Designer. This software also had built-in batch distillation models and allowed you to run your whole process as a batch process. Here we use both batch and rigorous distillation for an example. After adding streams and components to the model that you are using, you can toggle through the menus and input your specifications. We were not able to specify the number of trays that we wanted within the batch distillation column, but could in the rigorous column. Something important to note here is that though it may appear we have a distillate and bottom stream for both of these, there's nothing coming out of them, so it should in theory be able to mimic our project. As you can see here, you're able to add the input stream components to your feed and set the composition of your feed stream to the desired amount that you're trying to model. In this, we did 30% methanol and 70% water. Once the composition of your streams have been specified, we were able to change the number of stages and the stage efficiency. Here, there's also an option to change your stripping ratio, your reflux ratio, and so many more things within this one menu. We then ran the simulation, and the results that we were able to obtain were very similar to those that we got from running our actual experiment. This is the TXY diagram that the software produced, and this is the TXY diagram that we produced ourselves. In addition, this is the XY diagram that the software produced, and this is the XY diagram that Ethan made. Even though we were not able to obtain Murphy efficiencies from the software, it is still notable that we produced similar results in our experiment and in the modeling.